Elon Musk is pushing the boundaries of aviation with his groundbreaking hypersonic jet, rumored to reach an astonishing speed close to that of light. This revolutionary aircraft not only promises to defy the laws of physics, but also opens the door to unimaginable travel possibilities. Imagine zipping from one country to another in less than 90 minutes. This new era of hypersonic flight could transform global travel, making the world feel smaller and more connected than ever before. Let's explore the incredible potential of this technology. Hypersonic flight and Elon Musk's involvement. SpaceX, under Elon Musk's direction, is rumored to be venturing into the realm of hypersonic technology, a potential game-changer in both military and commercial high-speed travel. Hypersonic vehicles, which travel at speeds exceeding Mach 5 times the speed of sound, represent the frontier of ultra-fast transit and defense applications. While SpaceX has not officially confirmed work on a hypersonic travel project, recent military contracts and technological initiatives suggest that the company is positioning itself as a significant player in this domain. In 2021, SpaceX secured an $8.5 million contract from the Air Force Research Laboratory to develop advanced thermal protection systems for hypersonic vehicles. Thermal shielding is a critical technology for hypersonic vehicles, as speeds beyond Mach 5 generate immense heat, necessitating advanced heat-resistant materials to protect the vehicle's structure and electronics. SpaceX's work on thermal protection, a field it has developed expertise in through re-entry vehicles like the Dragon capsule and the Starship's heat shield technology, aligns well with the needs of hypersonic travel. The contract indicates that the Department of Defense views SpaceX as a valuable contributor to hypersonic development, recognizing its innovative approach to material science and manufacturing. SpaceX's potential entry into hypersonics is especially significant given Musk's track record of transforming high-stakes industries, from electric vehicles with Tesla to space transportation with SpaceX. Musk has consistently pursued groundbreaking, ambitious projects, frequently challenging existing technological limitations. His approach to hypersonics could apply these principles, leveraging SpaceX's capabilities in materials, science, propulsion, and aerodynamics. While other companies and nations are also racing to master hypersonic technology, Musk's reputation as an innovator could position SpaceX to drive unprecedented advancements in speed and efficiency. Hypersonic technology has strategic military implications, and SpaceX's government contracts may initially focus on defense applications. For example, the United States military has a strong interest in developing hypersonic capabilities to keep pace with China and Russia, who are already advancing in this area. Hypersonic vehicles are difficult to intercept due to their speed and maneuverability, making them an attractive option for both offensive and defensive military purposes. SpaceX's work on the materials and engineering required for these extreme conditions could therefore directly contribute to United States national defense objectives, enhancing SpaceX's role as a key defense contractor. Speculation also surrounds the potential for SpaceX's hypersonic technology to expand into commercial applications. Point-to-point hypersonic travel on Earth, for instance, could revolutionize air travel, dramatically reducing travel time between cities. While the technology is in its infancy, Musk has previously hinted at ambitions to transform terrestrial transportation. Achieving commercial hypersonic travel, however, would involve significant hurdles, including regulatory approval, infrastructure development, and cost reduction. Despite these challenges, Musk's reputation for pioneering complex, previously unimaginable solutions leaves the door open to the possibility that hypersonic travel might one day benefit the commercial sector as well. Given Musk's history of challenging industry norms and advancing disruptive technologies, his involvement in hypersonics could ultimately drive innovations with broad implications for defense and potentially global travel. The Concorde's legacy. Speaking of commercializing supersonic aircraft, we can't overlook the first ever attempt made in this direction. You will be surprised to know that it's not a modern-day goal. In fact, work on introducing supersonic planes for everyday passengers began around half a century ago. The Concorde was an iconic supersonic passenger jet that represented the peak of aviation technology during its 27 years of service. Developed through a collaboration between the British Aircraft Corporation and French aerospace company Aerospatiale in the 1960s, the Concorde was designed to travel at twice the speed of sound, cutting transatlantic flight times dramatically. For example, it could fly from New York to London in just over 3 hours, a journey that typically took more than 6 hours in subsonic aircraft. Despite its groundbreaking speed, the Concorde faced several limitations. One major issue was its inability to achieve hypersonic speeds. The aircraft could only reach Mach 2, far below the speeds required for true hypersonic flight. Additionally, operating the Concorde came with significant challenges. Its high fuel consumption, maintenance demands, and noise levels made it commercially unfeasible for many airlines. As a result, only British Airways and Air France operated the Concorde, and its high ticket prices and limited capacity meant it never became a mainstream choice. The aircraft was retired in 2003 due to these economic issues, compounded by the tragic crash of Air France Flight 4590 in 2000 and the impact of the 9/11 attacks on air travel. However, the Concorde's legacy lives on in the continued pursuit of supersonic travel. Today, companies like Hermes are working to revive and surpass the Concorde's achievements by developing new technologies aimed at achieving hypersonic flight. Hermes, for instance, is focused on creating passenger aircraft that could fly at speeds of Mach 5 or higher. Their goal is to revolutionize air travel, offering 90-minute transatlantic flights that would make long-haul travel dramatically faster and more efficient. These new developments aim not only to revive supersonic travel, but to overcome the economic and technical challenges that limited the Concorde's success, such as its high operating costs and limited range. The future of supersonic and hypersonic flight remains uncertain, but the Concorde's history provides a solid foundation for the next generation of advanced aviation technology. While the Concorde was a symbol of luxury and technological innovation, its legacy has paved the way for exciting developments in the realm of high-speed travel. Hypersonic speed versus commercial aviation speeds. Hypersonic technology holds great promise for the future of air travel, but there are many challenges that still need to be solved. Hypersonic speeds start at Mach 5, which is about 3,836 miles per hour, nearly 7 times faster than the speed of a regular commercial airplane. This means that flights could be much quicker, with a trip from New York to London, which usually takes about 7 hours, potentially being reduced to just 90 minutes with hypersonic travel. That sounds exciting, right? However, before this can happen, there are a number of technical problems to overcome. One of the biggest challenges is the intense heat generated when traveling at such high speeds. At Mach 5, the aircraft experiences temperatures higher than 3,600 Fahrenheit. This heat is powerful enough to damage the airplane and its systems. To handle this, new and stronger materials are needed. Traditional materials, like those used in regular planes, would simply burn up under such high temperatures. Researchers and engineers are working hard to create special materials that can survive and function in these extreme conditions. Managing the heat is just one part of the problem. To travel at hypersonic speeds, special engines need to be used. One of the most promising designs is the scramjet engine. A scramjet is a type of jet engine that works at speeds greater than Mach 5. This engine relies on the speed of the plane itself to compress the air before it enters the engine. This makes scramjets more efficient than traditional engines at these high speeds. However, they also need to deal with the enormous heat that comes with hypersonic flight. To help keep the engine running at its best, cooling systems are being developed. For example, Reaction Engines, a company that's working on hypersonic technology, is testing a system that cools the air entering the engine before it gets too hot. This pre-cooler technology helps reduce the temperature of the incoming air quickly, allowing the engine to work better and last longer. This technology is crucial to making hypersonic flight a reality, because without it, the engines would overheat and fail. Another important step in advancing hypersonic flight is finding the right kind of fuel. Traditional fuels used by regular airplanes wouldn't be enough for these speeds, so researchers are exploring alternative options. One interesting choice is hydrogen. Companies like Defies are studying how hydrogen can be used in hypersonic planes. Hydrogen is lightweight and burns cleanly, which makes it a good option for traveling at such high speeds. Hydrogen fuel could also be more efficient at the high altitudes and speeds needed for hypersonic travel. Using hydrogen might also help make hypersonic flights more environmentally friendly, which is another important concern for the future of aviation. Several countries and companies are investing a lot of money into developing hypersonic technology. In the United States Air Force and NASA are funding much of the research, but private companies such as SpaceX are also playing a big role. These organizations are testing different technologies and exploring ways to make hypersonic flight a reality. However, most of the research so far is focused on defense and military applications. While there is a lot of excitement about the possibility of commercial hypersonic flights, we are still a long way from seeing this technology used for civilian air travel. Hypersonic commercial flights face many obstacles before they can become a part of everyday life. One of the biggest challenges is cost. Hypersonic technology is extremely expensive to develop and test, and it will take time to make it affordable for regular passengers. Safety is another major concern. Flying at such high speeds comes with risks, and engineers must ensure that the planes can protect passengers in the event of any issues. Additionally, there is a need for new airports and infrastructure to support hypersonic flights. Right now, no commercial airports are equipped to handle these planes. Experts agree that hypersonic commercial flights are still many years away. Even though the technology is advancing quickly, it will take time to solve the problems of heat, fuel, and cost. More testing and approval from aviation authorities are needed. However, the future is bright. SpaceX's X-1 fighter jet. Imagine a fighter jet so advanced it was initially mistaken for a UFO by the Pentagon. Some viral videos and speculative reports have suggested the creation of a futuristic jet capable of Mach 6 speeds and UFO-like camouflage, and carrying advanced weaponry. This shocking aerospace revelation comes amidst global tensions and ongoing conflicts, potentially reshaping the landscape of modern warfare and space exploration. SpaceX's X-1 fighter jet is imagined to be capable of reaching speeds of Mach 5. This would place it in the category of hypersonic aircraft, which are currently an area of research for both military and civilian applications. This aircraft challenges existing missile defense systems, highlighting the fascinating intersection of technology and military prowess. Hypersonic speeds allow for rapid travel across the globe, dramatically reducing flight times. The idea of revolutionary camouflage technology might refer to advanced stealth technology that would allow the X-1 to be nearly invisible to radar or infrared detection systems. This means X-1, created after years of classified research and development at SpaceX, has powers that appear to defy the basic rules of physics. The capacity to attain hypersonic speeds of up to 4,600 miles per hour, more than double the speed of the famed SR-71 Blackbird, is essential to this breakthrough aircraft. This incredible speed is reached with the utilization of a tiny space shuttle engine, which was previously only seen in SpaceX's Hawk hypersonic missile. The integration of this propulsion system into a combat jet constitutes a significant advancement in aeronautical engineering. This stealth capability is so effective that it initially led to confusion within the Pentagon, resulting in the deployment of fighter jets in pursuit of what they believe to be an unidentified flying object. Some experts have predicted the X-1 uses SpaceX's Merlin and Raptor engines, which are real-life engines developed for the company's rockets and spacecraft. The Merlin engines power SpaceX's Falcon 9 rockets, while the Raptor engine is designed for the Starship spacecraft. These engines are known for their high efficiency and thrust, making them well-suited for high-speed aircraft and spacecraft. The X-1's performance is further boosted by its impressive fuel economy. SpaceX engineers reduced fuel usage by 30% compared to typical military planes. This upgrade not only increases the X-1's range and operational capabilities, but it also marks a significant advancement in sustainable aircraft technology. For example, the X-1 could execute a mission that would normally require many refueling stops for conventional fighters in a single flight, significantly improving its strategic worth. The most exciting part of the X-1 is its superior weaponry, which employs microwave technology. This sci-fi capacity enables the X-1 to possibly melt or destroy adversary aircraft's electronics from a distance. When aimed at personnel, a toned-down version of this system can create an unbearable sensation, described as being dipped in molten metal, forcing enemies to abandon their positions without causing permanent harm. This application is capable of revolutionizing battlefield tactics, minimizing casualties, and effortless capture of the enemy. The X-1's incredible altitude ceiling of 105,000 feet outperforms even the famed SR-71 Blackbird, which peaked out at roughly 85,000 feet. The X-1's extraordinary operating altitude puts it beyond the reach of traditional air defense systems, providing unique observation capabilities and strategic benefits. Commercial airliners normally cruise at altitudes ranging from 31 to 38,000 feet, but most combat planes fly below 50,000 feet. The X-1's capabilities far outperform existing top-tier fighter planes such as the F-35 Lightning II and F-22 Raptor. While both aircraft are powerful in their own right, with the F-35 reaching speeds of over 1,200 miles per hour and the F-22 somewhat quicker, they pale in contrast to the X-1's maximum speed. The fact that the X-1 is probably the most exciting supersonic aircraft to date does not mean that its development was without controversy. According to reports, tensions are rising between Elon Musk and the Pentagon over ownership and deployment of this advanced technology. While Musk views the X-1 as a potentially game-changing strategic asset, military establishment leaders are wary, igniting a complex discussion about the role of such advanced technology in modern battle and the balance between private innovation and national security objectives. Although the X-1 is designed primarily for military purposes, the technology developed for such advanced aircraft could have civilian applications, particularly in the development of hypersonic civilian airliners. Hypersonic flight could significantly cut down long-distance flight times, enabling travel from one side of the planet to another in a matter of hours instead of the typical half-day or longer. Challenges in hypersonic flight. Developing hypersonic technology presents significant technical challenges, particularly in the areas of temperature management, propulsion efficiency, and material durability. One of the most daunting hurdles is handling the extreme temperatures generated during hypersonic flight. At speeds exceeding Mach 5, the friction between the vehicle and the air creates intense heat, requiring advanced thermal protection systems to prevent structural damage. For instance, materials must be able to withstand temperatures as high as 2,550 degrees Fahrenheit for sustained periods without degrading or causing performance loss. In addition to thermal challenges, managing propulsion efficiency is a key concern. Traditional jet engines struggle to operate at such high speeds, and hypersonic flight demands specialized propulsion systems like scramjets or dual-mode ramjets. These engines must not only endure the extreme heat, but also remain effective in a range of flight conditions, including during rapid acceleration and high-altitude cruises. Designing airframes and propulsion systems that integrate seamlessly without compromising performance is a significant engineering task, as even slight temperature fluctuations can cause thermal and structural distortions. Moreover, the materials used in hypersonic vehicles need to be both lightweight and extraordinarily heat-resistant. Advanced composites and ceramics, such as ceramic matrix composites and high-entropy alloys, are crucial for meeting these needs. These materials can endure the high-enthalpy conditions experienced during hypersonic flight, providing the necessary durability and weight efficiency. However, creating these materials and integrating them into vehicle designs remains an ongoing challenge, requiring breakthroughs in manufacturing and testing techniques. While hypersonic flight has primarily been associated with commercial air travel, the potential applications extend far beyond this. Military forces are keen to leverage hypersonic technology for high-speed weapons and defensive systems. For example, hypersonic missiles could drastically reduce response times and enhance precision targeting, making them a game-changer in modern warfare. Hypersonic technology also holds promise for space exploration, offering the potential for faster space travel and more efficient launches. To realize these applications, significant advancements in material science and propulsion technologies are necessary. The development of lightweight, high-temperature materials that can withstand extreme conditions will be critical for the success of both commercial and military hypersonic aircraft. Additionally, refining propulsion systems to operate efficiently at these high speeds, particularly for long durations, is another key area of focus. These advancements are not only essential for hypersonic aircraft, but could also revolutionize industries such as aerospace, defense, and even space exploration. Hermeus's hypersonic flight ambitions and the Chimera engine. Today, companies like Hermeus are working to revive and surpass the Concorde's achievements, with the Chimera engine being one of the key innovations. This engine represents a significant leap forward in hypersonic propulsion technology, combining the power of a turbine-based combined cycle engine with the versatility needed for speeds beyond Mach 5. The Chimera engine has been designed to operate efficiently across a wide range of speeds, transitioning from turbojet mode at low speeds to ramjet mode as it accelerates to hypersonic velocities, making it capable of reaching speeds well over Mach 5. This dual-mode capability is crucial for hypersonic flight, as it allows for the engine to function optimally at different flight phases. Turbojet engines, like those in conventional aircraft, perform well up to Mach 2.5, while ramjets, which are more efficient at higher speeds, only become effective as speeds exceed Mach 3. The Chimera engine overcomes this gap, offering a unique solution for hypersonic flights. One of the major engineering challenges in developing such an engine was managing the transition between turbojet and ramjet modes. Hermeus, in collaboration with the Notre Dame Turbo Machinery Laboratory, successfully tested this transition, a critical milestone in proving the feasibility of the turbine-based combined cycle system. To test this, Notre Dame Turbo Machinery Laboratory developed a special facility capable of simulating the high-speed conditions needed for these tests, running simulations that replicated the Mach 4 conditions expected in flight. The tests were conducted in phases, allowing engineers to tweak the system and improve it between trials. In addition to the technical aspects of the engine, Hermeus has strategically focused on cost-efficient development by using off-the-shelf components wherever possible. This approach reduces production costs and accelerates development. It also enables faster iterations, which is key in a competitive and rapidly advancing field like hypersonics. By leveraging existing technologies, Hermeus can allocate resources more effectively, ensuring that the project remains on track to meet its ambitious timelines. The successful demonstration of the Chimera engine's ability to transition between modes is a major step forward in the development of hypersonic technology, with significant implications for both commercial and military aviation. The next phase of development will involve refining the engine further and preparing for flight tests with a full-scale model. Quarter Horse Project and Testing. The Quarter Horse Project is an ambitious hypersonic flight testing program aimed at revolutionizing high-speed flight. This project, led by the aerospace company Hermeus, involves a series of prototypes designated Mk0, Mk1, Mk2, and Mk3 that will progressively push the boundaries of speed and flight technology. The first prototype, Mk0, is primarily a ground test vehicle. Unlike the later prototypes, it will not take to the skies. Instead, Mk0 will be used for essential systems integration testing. This involves validating key aircraft systems, including propulsion, avionics, hydraulics, and control systems, before any flight testing begins. Mk0's primary role is to test the vehicle's performance on the ground, including systems like remote command and control for taxiing. By doing so, it sets the stage for more advanced flight tests and helps reduce risks for future prototypes. The next prototype, Mk1, is scheduled for flight testing and will focus on high-speed takeoff and landing tests. While it won't reach hypersonic speeds, it will demonstrate the aircraft's ability to handle the stresses of high-speed flight. Mcone will be powered by a GE JD5 jet engine, which is capable of generating around 3,500 pounds of thrust. This engine will allow the prototype to test subsystems such as ground operations and human factors, preparing the way for more advanced versions. Hermeus's rapid iteration approach means that this prototype will be developed and tested in less than a year, continuing a pattern of fast-paced innovation. After Mcone, Hermeus will develop the Mk2 prototype, which is expected to break the sound barrier and reach speeds up to Mach 3. This phase of the program will focus on testing supersonic flight capabilities, and will be a critical step toward achieving the hypersonic speeds required for the final prototype. The ultimate goal of the quarter-horse program is to achieve hypersonic flight, and the Mk3 prototype will be the one to demonstrate this capability. The Mk3 will feature the advanced Chimera engine, which will transition from turbojet to ramjet mode during flight. This technology is key to achieving speeds greater than Mach 5 and potentially breaking speed records, such as the 1971 SR-71 Blackbird record. The development of these prototypes is part of Hermeus's broader strategy to create a family of aircraft capable of flying at hypersonic speeds. This will not only advance military and commercial aviation, but also set the stage for future vehicles like the Dark Horse and Halcyon. We hope you enjoyed this video. Stay tuned for more.